Meet Alex Apili, the physics oracle. For over 20 years, he has ignited minds and shaped future through the power of physics, from bustling classroom in Kaduna to quiet labs in Benin City. His teaching have echoed across Nigeria, transforming students into scholars, thinkers, and innovators. His secret, a rare gift of making the complex feel simple. To his students, equations become stories, and theories become tools for transforming the universe. Alex Apili isn't just a teacher, he's a mentor, a guide, a legend in the world of science education. Across Nigeria, those who once sat in his classroom now lead in tech industries, research, and education, all carrying forward the legacy of the physics oracle. Alex Apili, inspiring minds, shaping destinies, one lesson at a time. At the end of this lesson, the student should be able to: one, define wave; two, state the types of wave; three, state examples of wave based on the classes of wave that will be discussed. See you in the lesson. Good afternoon, students. Today we're going to be looking at wave motion. So we're going to take the definition of wave, look at types of wave, therefore classification of wave. A wave is a disturbance which travels through a medium, conveying energy from one point to another without disturbing the permanent particles of that medium. For example, water is made up of what? Formula H2O. When in such a wave, when energy is transferred, the particles are not broken into individual components of that water. For example, hydrogen and oxygen. So it's only a disturbance. Examples of wave we have, for example, we have ripples spreading from water, ripples spreading from water, ripples spreading from water when stone hits the water surface. Then we have another example. We have the oscillation of a rope when jerked from one end. The oscillation of a rope when jerked from one end. So that's another good example. Now let's look at types of wave. Now we will classify wave, number one, based on the mode of transfer. Waves, there are waves that need material mediums, and there are also those that do not need what? Material medium. The waves that need material medium to convey energy from one point to another, they are referred to as mechanical wave. Those that do not require material medium, they are known as what? Electromagnetic wave. On this basis, let me quickly write that. So we say mode of transfer. Mode of transfer. So under the mode of transfer here, we have mechanical wave. Then we also have electromagnetic wave. Now we give examples. Let's give examples for mechanical wave. For mechanical wave, we have example is what? Water wave. Water wave. We're talking about water wave now. We are looking at ripples spreading from water as a result of what? Disturbance from a stone hitting the surface of the water. Then we also have oscillation of a rope or a spring when jerked from one end. Oscillation of a rope when jerked from one end. Then we can add this sound wave. Sound wave. Sound wave, for example, when a bell is jingled, you need a bell to create sound. So you require what? That material called bell. Now let's look at examples of electromagnetic wave. So we'll talk about examples of electromagnetic wave. Here we are looking at Here we are looking at a family, the Relogy family. The Relogy family. What does this acronym Relogy? What does it imply? R stands for radio wave. Radio wave. The I stands for infrared. Infrared. S stands for light. Now we can say the sun. The sun is an example of light. Then we ask for you stand for ultraviolet. Ultraviolet. Then X stand for X-ray. Then G stand for gamma ray. So these are examples of wave under electromagnetic wave and also what under mechanical wave. Now we now go further into further classification. Here we look at direction of oscillation and propagation. Direction of oscillation and propagation. Direction of propagation and oscillation. Under direction of oscillation and propagation, again, we are classifying wave as transverse wave, and longitudinal wave. Now for transverse wave, we take examples of transverse wave. In transverse wave, we have example. Again, we have that all Relogy G, they are examples of transverse wave. Recall, the Relogy G is an acronym. R stands for what? Radio wave. I stand for infrared. S stands for light. U for ultraviolet. S for X-ray. And G for gamma ray. They are examples of what? Transverse wave. And remember, they are also the family of what? The electromagnetic wave. They have specific characteristics. They have a common, they are what we call a common speed, and as the speed of light, which is about 3 times 10 raised per 8 meter per second. So they have that common speed. So that is that about the Relogy family, which are examples of transverse. Then we'll go to longitudinal wave. Again, there's something, before we go to longitudinal wave, there's something we need to describe by transverse wave. Recall we said direction of propagation and what? Oscillation. In transverse wave, now you see that in transverse wave, the oscillation is perpendicular. Oscillation is perpendicular to propagation. Oscillation is what? Perpendicular to propagation. We'll talk about using the word perpendicular. What does that mean? It means what? 90 degrees. It means what? 90 degree. So that's for transverse wave. Let's draw that. Now in the diagram, we can represent that. Look at the diagram. Now when you have a wave-like structure, that is the shape of a wave, you can see that here, you can take the amplitude. The amplitude here, or the vertical line from the rising is exactly at what? 90 degree to the x direction. Here we have the y and the x direction. You can see that the oscillation is the rising, and it's making angle 90 with the x. So we refer to that as what? The oscillation. And where x represents what? Direction of what? Propagation. So that is that. Then we come back to what? Longitudinal. In longitudinal wave, what are the examples? What are the examples of what? Longitudinal wave. What are the examples of what? Longitudinal wave. Again, we have e.g. Here we give sound wave. Sound wave. So sound wave is a clear example of longitudinal wave. Sound wave. Now, explaining longitudinal wave with a clear diagram, here we see that direction of propagation is parallel to the direction of oscillation. Now we use diagram to represent, let's use diagram to represent longitudinal wave. In longitudinal wave here, we see that they are parallel. Oscillation is parallel. There are two parallel or two line. Oscillation is parallel to propagation. Oscillation is parallel to what? Propagation. So that is that. So we stop here right now and go straight to types of, go straight to terms used in describing wave. In the lesson ahead, please be prepared to leave in the comment section questions and state area of difficulty. Looking forward to see you there.